We're going to be talking about Beer's Law, and this is going to be in preparation for the lab that you're going to do in class. So Beer's Law is based in the electromagnetic spectrum. So substances absorb light and they also transmit light. So we can use Beer's Law to determine how concentrated a solution is based on how much light it absorbs. So this principle, Beer's Law, is based in absorption spectroscopy, which is a way to measure the concentration of chemical compounds. Here I have a picture of an absorption spectrum for chlorophyll, and you can see its wavelength versus the absorption of light. So you can see that it peaks in the violet and the orange-red and dips in the green. So what happens is green leaves, which has chlorophyll in it, absorb all other colors except for green. Therefore, we see the leaf is green. Another use of spectroscopy is in wine analysis. So here you can see that the wine analysis is the wavelength versus the absorption for red and white wines, and you can clearly see that they've labeled the white wines as a lower wavelength than the red wines, as a lower absorption, and the red as a higher absorption value, which makes sense because red wine is darker than white wine, therefore it would absorb more light. So talking about absorption versus transmittance. So when light strikes a substance, the light is absorbed by that substance. Depending upon how concentrated the substance is, it will absorb more or less light. Here I have an example of a nickel chloride solution. So we're going to figure out the difference between absorption and transmittance using this solution, and I'm going to show you how they relate to concentration. I'm going to use a red laser, and you can see at the bottom its concentration, and I increase the concentration, and I'm currently clicked on absorption. So if I increase the concentration of the solution has more nickel chloride in it. Nickel chloride is what makes the solution the green color. As I increase the concentration, my absorption also increases. This is showing as you increase the concentration, that solution is going to absorb more light. Therefore, my absorption value is going to go up. You can also see that as I have a lower concentration, the red beam is able to travel through the solution more concentrated. And as I increase the concentration, the beam on the other side of the solution, coming out of the solution, gets lighter and lighter and lighter. And that's because that light is being absorbed in the nickel chloride solution. Now let's look at what transmittance does. So if I go back down to a zero concentration, I have 100% transmittance. That is showing that my laser is going straight through the solution because none of the light is being absorbed. So as I increase concentration, my transmittance is going to decrease, showing an inversely proportional relationship. As concentration goes up, transmittance goes down. And that's because that light is being absorbed, therefore not as much of it is being transmitted. So we have an inverse proportional relationship, and then with an absorbance and concentration, we would have a direct proportional relationship because they're going up together. In your lab, you're going to be using a device called a colorimeter. This colorimeter is going to use light to pass through the solution, striking the detector on the opposite side of the contraption. The wavelength of light used should be one that is absorbed by the solution. We're going to be using a nickel sulfate solution in the lab, which is going to have a very similar color to this green nickel chloride solution. So in this example, I used a red laser. The reason why I used the red laser, which has a wavelength of 678 nanometers, is because of this little color wheel down here. So if a nickel sulfate solution is green, that means that it's absorbing all other colors except for green. So if you look at the opposite of green, it's red. So in your lab, you're going to be using the color red as the laser that's going through your solution because that color is going to be absorbed by the solution. So what are we actually going to be doing? You are going to find the concentration of solutions of nickel sulfate, and you're going to be giving a solution with an unknown concentration. So you're going to measure the absorption of each of the different solutions, one of them with an unknown concentration, and you're going to determine the concentration using Beer's law. So Beer's law relates concentration to absorption. So the more concentrated a solution is, the more light will be absorbed. So you can create what's called a Beer's law curve, as you can see in this picture right here. It's a direct proportional relationship between concentration and absorption. And you're going to do that in Google Sheets, and I'm going to show you how to do that with some the data set. And then you're going to find the unknown concentration. So here I have concentration versus absorption data. And you can see that the absorption is increasing and the concentration is increasing as well. So I'm going to graph the concentration versus absorption. So I'm going to highlight the data, click on Insert Chart. The chart type that I'm looking for in this data set is a scatter plot. And then I'm going to go to Customization, and I'm going to add a linear trend line and insert the graph. Alright, so here's what my data looks like. So what I can do is I can find the equation of this line to determine the concentration of the unknown solution. So to find the equation of the line, I'm going to need to find the slope, and I'm going to need to find the intercept. So to find slope, the equation is equals slope, and then you want to highlight your absorption data, comma, highlight your concentration data, and then close your parentheses. To find the intercept, you press equals intercept, highlight your absorption data, comma, highlight your concentration data, close your parentheses. So now my equation of my line would be y equals 2.5x plus 1.85. Oh, 1.86, I'll round that. Actually, I'll round that as well. Okay, so y equals, so the complete equation of the line is y equals 2.54, which is the slope, plus 1.86, which is the intercept. So I can use the equation of the line to solve for my unknown concentration because concentration is my x value. I'm looking to solve for x, and I can plug the absorption value in for y to solve for x. So the equation would be 2.7431 equals 2.54 x plus 1.86. So when solving for x equals 0.35. Therefore, the concentration of my unknown solution with an absorption value of 2.7431 is 0.35, which makes sense if you look at the data. So the 0.35 would be in between the 0.32 and 0.4, and the absorption fits in between those two absorption values as well. So that would make sense. So again, we're going to be using Beer's law to find the concentration of an unknown solution using absorption data.